So a few months ago, I had this crazy idea that I would build a general purpose web search engine. Now, I haven't been spending all of that time building this, and in hindsight, maybe I should have, because as it turns out, building a search engine is really hard. There's a reason that there are only a few search engines out there. But anyway, that's what we'll be doing in this video. Hey everyone, welcome back to Dev Parkour. In this video, I want to kind of demystify what goes on in your favorite search engine. Now, just to set expectations, I did not rebuild Google. Not even close. But we'll get to that in a minute. For this project, I wanted to focus on 4 specific areas to optimize. The first 2 of which are the common metrics used to score information retrieval implementations. First, we have retrieval, which basically means the percentage of pages that are valid for a given search term that actually appear in the search results. I'll give you fair warning, our search engine will fail miserably at retrieval, primarily because I only crawled 10,000 pages linking to approximately 130,000 total pages, which together represents less than a third of a percent of the estimated 4.2 billion web pages on the World Wide Web. That's 300 thousandths of the entire web. Second, we have relevance, meaning that the first page in the list of results should be the most appropriate for that search term. This can be a little subjective, but Google changed the landscape of search back in the day with something called PageRank. The idea that individual web pages' meaning and importance were directly correlated with the links to them from other pages, a concept we'll leverage here even if we don't implement it exactly the same way. Third is speed. When I type a search term into the web interface, I should get results back more or less instantaneously. Google makes a big deal about this, even now that all search engines work essentially the same way, by highlighting the number of results and how long it took to render the page right at the top of the search results. The way they can do that is by doing most of the heavy lifting behind the scenes so that the web interface just needs to run a very simple, fast database query. For our search engine, we'll actually divide this further into 3 pieces. A crawler that finds web pages and downloads relevant information about them, an indexer that builds up a map of search terms to pages, scored by relevance, and a web interface that just queries the index for the entered search term and orders by the relevance score. And finally, we'll make a distinction between search and query. Some search engines, especially purpose-built systems or those designed for a more technical audience, support a SQL-like syntax to limit and filter results by exact matches. The system we'll build will be more in the spirit of Google and Bing, where everything is treated as a search term. So first things first, we need to discover a list of 10,000 web pages and the links between them. What I ended up doing was starting with my personal homepage at brianparks.me, which works really well because it actually has a good number of links to other pages on it, analyzing the page for all of those outbound links, and adding them all to the database. Then, performing the same steps on each of those pages, then the pages they link to, and so on. Note that in the code you see here, I wasn't going for efficiency. I was going for readability and getting the code written as quickly as possible. Once I had this list of pages and links, I could start indexing each page. The process here is pretty straightforward. For each page, which I pull from the database in batches of 100 to ease memory consumption, I pull all unique words from the incoming links, then count up all the number of links using each of those terms for the page's relevance score for that term, and saving all of this to a third database table. This means that building the web UI is super simple. All I need is a small web form with a text box and a button, and a little bit of backend code that looks up the term in the database. You'll notice that my code only handles a single search term. To handle a multiple word search term, I do a union of this query performed on each word, then group by page and aggregate the scores. Okay, moment of truth. Let's see how we do, and just for fun, let's compare to Google. That was amusingly bad. No, I take it back. That was absolutely awful. So what are some things we could do to make it better? First, we could crawl more of the web. We can't retrieve what we haven't discovered, and many of the results that Google showed us are pages that we didn't discover. Second, we can include at least certain parts of each page in the indexing process instead of only using incoming links, something like header tags. Third, we can add an authority score to each page so that a page that is closer to the root of a website is given more importance than a page further down. We can also use this when we're computing term relevance scores, so a link from the home page of a site means more than a link from deeper down a website. So like I said, search is hard. This video only scratches the surface of what search engines do, but I hope you enjoyed it nonetheless. Stay tuned for more videos like this, and if you liked this format, please be sure to hit that like button. If you're not already subscribed to the channel, I would love if you would subscribe and hit that notification bell. And as always, if you have any thoughts or questions, please be sure to leave them in the comment section down below. Thanks for watching, and I'll see you again soon.